Welcome, dreamer. Once again, you've found your way to this quiet corner of the universe where minds drift free from the day's relentless noise. This is the Sleep Scientist, and tonight we embark on a journey beyond anything previously imagined, far beyond Earth, far beyond our sun, to a star so immense and ancient that if it occupied our sun's place, it would devour Mercury, Venus, Earth, Mars, and even mighty. Its name is Betelgeuse. This red supergiant glows like a cosmic ruby in Orion's shoulder. Light from its surface, the fastest phenomenon in existence, requires more than 6 centuries to reach us. When your eyes find it in the night sky, they witness not its current state, but how it appeared in the 14th century. 640 years of cosmic delay separate us from this stellar giant. Tonight, we explore the impossible. Tonight we ask, what if you fell into Betelgeuse? Picture yourself standing outside on a crisp winter evening. Stars pierce the cold air with crystalline clarity. Your gaze finds Orion, mythology's great hunter, and traces his 3-star belt. Above them, slightly leftward, a faintly reddish point catches your attention. It almost seems alive, pulsing with an otherworldly breath. That distant ember is Betelgeuse. Now imagine impossibly that instead of merely observing, you could travel there. Picture diving into that fiery surface, sinking into its incandescent heart, experiencing with every sense the life of a dying star. It sounds like dreaming. It sounds like madness. It sounds like an adventure only your mind can safely undertake from your comfortable bed. Close your eyes, let your body settle. Together, we'll journey there. Before leaping into this colossus's embrace, we must understand its nature. Betelgeuse, pronounced Betelgeuse, ranks among the largest naked-eye visible stars. Astronomers estimate that if placed at our solar system's center, its photosphere would extend beyond Jupiter's orbit. That represents a radius of nearly 900 million kilometers. Our sun, by comparison, measures a mere 1.4 million kilometers in diameter. Betelgeuse's diameter exceeds our sun's by more than 1,000 times. Yet its mass isn't proportionally greater, perhaps 10 to 20 solar masses. This reveals something fascinating. Betelgeuse is extraordinarily diffuse, its outer layers resembling cosmic fog made of superheated plasma. Betelgeuse is ancient by stellar standards. Massive stars burn fuel rapidly, living fast and dying young. While our sun enjoys a 10 billion year lifespan, Betelgeuse may be only 8 to 10 million years old, already approaching its final act. Soon, perhaps tomorrow, perhaps in 100,000 years, it will explode in a spectacular supernova, outshining the full moon in Earth's sky. But we're not here to discuss its death, not yet. We're here to fall inward. In your mind, envision the departure. No ordinary spacecraft carries you, no helmet, no oxygen tanks required. Here in imagination's realm, your essence simply flows like a current away from Earth. Blue fades to black. Atmosphere thins to nothingness. Below, our planet becomes a marble, then a bead, then a pale, lost in darkness. Your speed transcends anything ever achieved. Not thousands of kilometers per hour, not millions, but velocity limited only by imagination's reach. Galaxies drift past like distant clouds. Orion grows larger in view, its bright belt stars sharpening into individual points of fire. Their swelling in size, Betelgeuse reveals its surface roiling and flickering with titanic storms. As you approach, Betelgeuse no longer resembles a star. It no longer appears spherical. Its enormity means you cannot perceive its edges. The horizon curves so gradually it seems almost flat because the scale overwhelms human comprehension. The surface refuses smoothness. It appears modeled vast convective cells, each Earth-sized, rise and fall, carrying heat from stellar depths to surface layers. Some regions glow brighter, others dimmer, in shades of deep orange, crimson, and molten gold. Plasma jets, each many times Earth-sized, leap from the surface and cascade back, like waves on a cosmic ocean. Though you feel no wind, movement surrounds you completely. The surface churns in slow, graceful violence. Betelgeuse's outer layer, the photosphere, literally light sphere, maintains temperatures around 3,500 Kelvin. Much cooler than our sun's 5,778 Kelvin, yet still hot enough to vaporize anything instantly. But in our mental journey, immunity protects you. Drifting downward through thin plasma feels not like falling through air, but moving through extremely diffuse mist. Light surrounds you from every direction in soft, all-encompassing radiance. Your eyes, if they could still function, would see nothing solid. Everything is motion, heat, and light. Particles here spread far apart. A cubic meter of this surface might weigh less than your bedroom's air, yet each particle burns as searing hydrogen or helium, moving at incredible speeds. Minutes pass in your descent, yet you remain in the star's outer layers. Such as Betelgeuse's vastness, traveling from edge to core, could require weeks of constant descent at unimaginable speeds. Gravity here behaves strangely. Because Betelgeuse is so enormous and diffuse, surface gravity actually registers less than Earth's, perhaps only a few times stronger. Though the mass is immense, its distribution across such huge volume means you don't feel overwhelming pull. Unlike falling into a black hole, where tidal forces would tear you apart instantly, this descent feels slow, inevitable, dreamlike. Here, in this glowing sea, you are simultaneously utterly insignificant and intimately connected to the star. Every atom in your body once resided in a star like this, long before our sun's birth. Stars serve as the universe's great alchemists, forging elements that create planets, oceans, forests, and you. As you sink deeper, the sensation isn't of entering alien territory, but of returning home. We pause here, suspended in Betelgeuse's radiant embrace. But our journey's true beginning lies much farther away, across a vast, silent road stretching between us and this ancient star. A road few truly imagine, and fewer still comprehend. Tonight, we retrace that cosmic highway. Temporarily leaving this fiery surface, we step back to the small blue world where you were born. We'll traverse the space between the cold, the darkness, the loneliness of the cosmic ocean, so you understand just how distant Betelgeuse truly is. From Earth, Betelgeuse appears as merely a point of light. Winter months in the northern hemisphere offer the best viewing when it rides high in the sky, forming bright Orion's shoulder. The name derives from ancient Arabic, Italiza, meaning the shoulder of the central one. Centuries softened the pronunciation into Betelgeuse, yet its celestial position remained constant, always the great hunter's left shoulder. From your backyard, you might notice its faint red twinkle against the darkness. That twinkle, though charming, doesn't represent Betelgeuse itself, changing rather. Our atmosphere bending and distorting starlight during its final kilometers through Earth's sky to your eyes. Tonight's light began its journey over 640 years ago, around 1385, before telescopes, electricity, or printing presses. When these photons started traveling, candlelight illuminated the world. The night sky provided the only entertainment. Imagine deciding to visit Betelgeuse. First, you'd climb through Earth's atmospheric layers, each growing thinner and colder until no air remains. From low Earth orbit, our planet would dominate your view. Blue oceans, swirling clouds, the thin golden atmospheric curve against space's blackness. Betelgeuse would still appear as one point among thousands. Heading toward it, you'd pass the moon in days. Mars, with its dusty deserts and pale skies, would require months. The gas giants Jupiter with Earth-sized storms, Saturn with impossible rings would slide past over years. Beyond Neptune, the solar system's outermost official planet, you'd cross the Kuiper Belt, a vast field of icy debris from our system's birth. Beyond that lies the interstellar medium space between stars. It's not truly empty, yet so nearly so that millions of kilometers might pass without encountering a single atom. Even at light speed, 300,000 kilometers per second, the journey would consume over 6 centuries. Aboard humanity's fastest spacecraft, the Parker Solar Probe. Moving at 700,000 kilometers per hour, arrival would take over 100,000 years. The road to Betelgeuse isn't traveled with rockets, it's traveled with imagination. Only your mind moves fast enough to reach it tonight. Along our mental journey, let's admire Betelgeuse's neighborhood Orion constellation. Many cultures have seen Orion as hunter, warrior, protector. His 3 bright belt stars, Al-Nonamum and Mintaka, point directly towards Sirius, the night sky's brightest star, and toward Betelgeuse itself. Flying toward Orion would reveal this familiar pattern as illusion. Orion's stars aren't actually close together in space, some are hundreds of light years apart, simply aligned to form recognizable shapes from Earth's perspective. Betelgeuse ranks among Orion's giants. But the constellation also harbors other massive young blue stars hotter, brighter, and more short-lived than even Betelgeuse. This stellar nursery witnesses star birth and death on cosmic timescales. Now, let's resume our fall. We've already arrived not in physical space, but in mental space. Betelgeuse appears not as a dot, but as a swollen, glowing sphere. It radiates orange-red light, soft to the eyes, yet hiding temperatures hotter than any earthly flame. Its outer edges are so diffuse that no sharp boundary separates space from star. Your drift into the photosphere occurs without realization, as darkness behind fades into deep, fiery haze. Before continuing the descent, let's appreciate the sheer scale. Betelgeuse's volume could contain 1.6 billion Earths. Even our Sun, our solar system's largest object, would appear as a tiny marble inside Betelgeuse's colossal shell. Standing near its surface, if standing were possible, you wouldn't see stellar curvature. It would resemble being a dust mote floating in an endless orange ocean center. No clear edge exists to aim for, only gradual changes in density and temperature with deeper movement. As you drift toward the upper atmosphere, temperatures climb 3,000, 4,000, 5,000 degrees Celsius. The heat isn't directional like standing near fire. It exists everywhere, bathing you in light and energy from all angles. Suspended in omnidirectional glow, every surrounding atom contributes to the radiance. In reality, instant vaporization would occur. But here, in thought, only pleasant warmth envelops you, like a perfect bath. The air, if we could call it that, remains thin, almost non-existent, yet alive with motion. Now we've arrived again. The vast interstellar emptiness has yielded to Betelgeuse's soft, radiant photosphere. Floating inside a star, your journey has only begun. From here, descent will carry us through layers, stranger and more beautiful than anything yet seen, until at last we reach this dying giant's heart. But that awaits the next chapter. For now, rest here. Let the glow embrace you. Allow this thought to sink in. You're more than halfway to a star's heart. Stars lack sharp edges. No line marks where void ends and stellar surface begins, unlike planetary boundaries. Betelgeuse's outer boundary isn't a wall, but fading, glowing mist. Earth-observed surface is what astronomers call the photosphere. The layer where gas becomes dense enough to radiate visible light freely into space. As you approach, no real surface exists. Only gradual atmospheric thickening occurs until complete surrounding. Interstellar spaces, darkness thins to deep orange haze. Background stars' points of light blur and vanish behind the growing radiance. Cold emptiness around you warms, softly initially, then with mounting intensity. Breathing here wouldn't involve air. Instead, hydrogen atoms, helium, and trace amounts of carbon, oxygen, nitrogen, and other elements, each searingly hot, moving at unimaginable speeds, fill the space. Temperature at this altitude reaches approximately 3,500 Kelvin, about 3,200 degrees Celsius. In reality, no human-made material could survive. Even the hardest metals would vaporize instantly. But in imagination's realm, warmth surrounds and penetrates from all directions rather than from a single source. Weightless, you drift in light so intense it lacks a source, because here, light exists everywhere. From distance, Betelgeuse appears deep orange or reddish. Inside its atmosphere, color becomes richer and more complex. Shades of gold, copper, and crimson swirl together. Massive convection cells, rising plasma bubbles, create brighter patches where fresh energy surges upward from depths. These regions glow in pale, almost golden light. Around them, cooler descending gas appears darker, burnt orange fading toward deep red. This mottled surface constantly shifts, but not like Earth's clouds. Patterns here change slowly over months or years. Each convective cell spans hundreds of millions of kilometers, large enough to engulf entire planets. Though now inside the photosphere, you've barely crossed the threshold. Betelgeuse's outer layers are so diffuse that days of travel might still keep you in what astronomers consider its atmosphere. Scale stops making sense. Distances are so great, layers so thick, that minds struggle to process them. It's as if usual perceptual rules have been quietly suspended. One strange sensation involves gravity, or rather, how gentle it feels. Despite Betelgeuse's mass being perhaps 15 to 20 times solar, its immense size spreads that mass so thinly that surface gravity stays surprisingly low, perhaps only slightly higher than Earth's. This means no crushing sensation. No violent pull toward the core. Instead, the fall is languid, like sinking through warm ocean layers. Sound can't be heard conventionally. Sound requires medium like air or water, and while plasma can transmit sound waves, here they move at frequencies far below human hearing range. But in imagination you sense it, a slow, deep pulse. Rhythm like cosmic creature breathing. Each breath might span months or years, yet you feel it nonetheless. The rising and falling of the star's giant convection currents, the endless energy cycle from core to surface. Deeper now, movement becomes clearer. Great plasma loops rise and twist, arching thousands of kilometers before folding back into the surface. Some rise so high they break free, drifting into surrounding space before cooling and fading. These aren't storms like Earth's hurricanes or lightning-filled clouds. They're far more vast and alien. Each could swallow Earth without notice, yet from here, they move slowly, too slow for real-time eye tracking. Motion must be trusted, invisible in human perception spans. The photosphere is only the beginning. Beneath lies the convective zone, where energy from stellar interior rises through plasma currents. Imagine boiling water in a pot. Bubbles rise from bottom, carrying heat to surface, while cooler water sinks around them. The convective zone operates similarly, except bubbles here are planet-sized, and the pot spans nearly 1 billion kilometers. Approaching this region, light intensifies. Plasma grows denser, hotter. The sensation transcends warmth. It becomes energy itself, flowing through and around you. Before crossing deeper into the star, you look back. Behind you, photosphere glow fades into space's black void. Orion's familiar shape has vanished, its stars lost in surrounding brilliance. From here, no outside exists anymore. Once fully entering the convective zone, complete surrounding occurs above, below, in all directions by the star's living substance. Many might feel small here, insignificant against such enormity, but perhaps it's better considered differently. There's no separation from this. Every atom in your body once resided inside a star, not unlike Betelgeuse. The calcium in your bones, iron in your blood, oxygen you breathe, all were forged in stellar hearts before scattering across the galaxy. There's no intrusion here. This is home. With that thought, you let yourself sink. The glow brightens. Heat intensifies. Plasma becomes more turbulent, and the soft, slow pulse felt before grows closer, deeper, like a heartbeat you're slowly approaching. The outside world has vanished. Only the star remains now, and you falling ever inward. Here we pause, dreamer. Ahead lies the journey through Betelgeuse's great convective sea, down toward the unimaginable heat and pressure of its core. But that comes in the next chapter. For now, breathe in the starlight. Inside a red supergiant, your journey has only just begun. We are deeper now. The photosphere's edge lies far above us, its shimmering layers slowly swallowed by the churning molten depths of Betelgeuse's convective sea. Light here feels thicker, not brighter in a way that hurts, but heavier, as though each photon carries weight. Then, there's gravity. When we imagine a star, especially one as massive as Betelgeuse, we picture overwhelming pull, crushing force dragging everything toward its heart. But here's the first surprise. Near the surface, Betelgeuse's gravity feels gentler than expected. Yes, it's massive, perhaps 15 to 20 times our sun's mass. But it's also vast beyond comprehension. A bloated sphere, hundreds of millions of kilometers across. This enormous size spreads its mass thinly, so surface gravity might only slightly exceed Earth's. Standing on a solid surface here, which of course is impossible, wouldn't flatten you. A steady pull would register, yes, but not violently. Gravity's strength depends on two factors: the object's mass and proximity to its center. The closer you are, the stronger the pull. On Earth, we're only about 6,371 kilometers from its center, very close in cosmic terms. So gravity feels strong and immediate. On Betelgeuse, the surface sits hundreds of millions of kilometers from its center. This enormous radius reduces the gravitational pull experienced. It's one of giants' paradoxes. The more they expand, the more their grip on outer layers loosens. This gentle gravity has consequences. Betelgeuse's outer layers bind only weakly to the star. Little is required, just strong convective current or energy wave from deep within to hurl plasma into space. This explains why red supergiants like Betelgeuse are unstable, constantly shedding material into void. Over the past 100,000 years, Betelgeuse has been surrounded by great gas and dust clouds. It once held close. Now, drifting outward to one day seed new stars and planets, picture yourself suspended here, deep inside the convective zone. Gravity still draws you inward, but descent feels unhurried, almost lazy. Like drifting downward in a warm, glowing ocean, guided not by speed, but by inevitability. All around, the star moves in slow motion. Enormous convective cells rise from below, carrying energy outward. Others sink, cooler and darker, drawn back toward inner depths. These colossal currents pull you along, each larger than worlds. Part of a giant's heartbeat you become. If we could measure it here, gravitational acceleration might be somewhere between 1.5 to 2 times Earth's, not crushing, but enough to ensure that once inward falling begins, no turning back exists. Unlike Earth falls, where ground arrives quickly, this journey is slow, drawn out by sheer stellar size. Even traveling at hundreds of kilometers per second, you might drift for hours, days, before reaching deeper layers. There's another strange thing about falling inside stars. On Earth, going deeper underground means more mass above you, and that mass pulls in all directions, partly canceling gravity from below. Inside stars, something similar happens. As you descend, layers above begin to pull upward slightly, reducing net gravity felt. Strangely, the deeper you go, the lighter you may feel until approaching the dense core, where gravity again grows fierce. Gravity can't be seen here, but its effects are visible. Towering plasma arches rise and bend back toward surface, whose particles are drawn into slow, spiraling paths. Even light itself curves ever so slightly in the immense gravity well. Yet it's not violent, not yet. The pull is patient, like a hand resting on your shoulder, gently but firmly guiding you inward. Though the core remains unimaginably far below, you can sense it a place of densities and temperatures beyond comprehension, where gravity becomes crushing and atoms themselves are stripped bare. Here in outer layers, that future feels distant. But Betelgeuse masters inevitability. No matter how slowly you fall, you will reach it. Strange to think that in this vast alien inferno's midst, you're moving toward the same process that once gave birth to matter in your own body. Stars like Betelgeuse live fast and die young, but in their deaths, they scatter heavy elements that make life possible. The gravity felt now is the same force that once pulled hydrogen together to ignite the universe's first stars. Without it, no planets, oceans, or living things would exist to drift here in awe. So you surrender. No longer fighting the descent. Light thickens. Plasma grows hotter, denser, more turbulent. Gravity holds you not as threat, but as promise. A promise that more exists, deeper mysteries waiting far below. The sound, or rather sense, of Betelgeuse's heartbeat strengthens. Convection pulses now feel like ocean swells, rising from unseen depths and washing past you in warm, glowing waves. Letting go, you fall deeper toward, where the slow giant's heartbeat becomes a roaring tidal force, and the star begins revealing true violence beneath its calm face. Hours, perhaps days, have passed since we breached Betelgeuse's surface. Time has lost meaning here. Each second stretches, elongated by hypnotic plasma churning, and gravity's gentle yet relentless tug. No sky exists above anymore, only dim red haze, diffused through layers upon layers of stellar matter. Ahead of us downward, a slow, endless gradient toward the star's heart. The first great ocean through which you sink is Betelgeuse's convective zone, where the star moves in colossal, churning cycles. On Earth, convection appears in boiling water. Hot liquid rises from bottom, cools at surface, and sinks again. In Betelgeuse, this process unfolds on almost incomprehensible scale. Each convective cell here could engulf our entire sun and still have room to spare. Picture rising plasma mountains, 100 million kilometers across. slowly rolling upward over months or years, while darker valleys of cooler plasma sink back down beside them. These aren't currents as known their entire heat and motion continents. We're caught in one such upward swell. Motion is slow. Months might pass crossing from one cell to another, but inexorable. Here, temperatures have climbed beyond 10 degrees Celsius, many times hotter than the sun's visible surface. It is an imagined scenario safe from harm. Heat isn't perceived as burning, but as all-encompassing presence. Heat is felt not with skin, but as deep internal vibration in every body atom. Pressure, too, increases. Though Betelgeuse's outer layers are thin compared to its core, they're still far denser than anything on Earth's surface. Imagine being suspended beneath kilometers of ocean, then replacing that water with molten hydrogen and helium, constantly moving. Silence might be expected here, but truthfully, stars alive with sound. Not as our ears detect, but in vast, low-frequency pressure and density waves. Betelgeuse hums. Its vibrations ripple through your body, slow and seismic. Some modes take years to complete single oscillations, like sleeping giants' slow breathing. In these vibrations lies information, the star's structure, instability, even hints of eventual collapse. Astronomers on Earth call this astroseismology starquake studies. Even while rising within convective current, gravity's net pull drags you inward. No solid ground exists here. Motion isn't like falling toward floor, but like drifting deeper into storm cloud. Your path curves, sways, and sometimes stalls as you're carried sideways by convection, then downward by sinking currents. Now a particle, a tiny speck in cosmic weather system. Deeper still, convective churning begins thinning out. Matter density increases, turbulence softens, and we approach transitional region where energy no longer transports primarily by giant boiling motions, but by photons, slow, patient journey. This begins Betelgeuse's radiative zone. Here, visible light is ancient. From the core, photons are born in nuclear fusion high-energy gamma rays. But stellar density is so great that these photons cannot travel freely. Instead, they scatter constantly, bouncing from particle to particle in random walk. In sun-like stars, photons might take hundreds of thousands of years reaching surface. In Betelgeuse, swollen and diffuse as it is, the path differs, but is no less labyrinthine. By the time light emerges at surface, it is transformed not the fierce gamma ray of birth, but warm red glow of supergiant skin. Here, in radiative layers, motion slows, less turbulence, fewer giant currents. Environment is denser, hotter millions of degrees now, but paradoxically, calmer in appearance. Energy moves here not in matter waves, but in light waves, invisible to our eyes, relentless in outward journey. If convection was the star's churning heartbeat, radiation is its silent breath. Gravity's pull begins subtly changing again. Remember, in outer layers, much stellar mass was above you, counteracting pull from below. But now, approaching central regions, more stellar mass lies beneath your feet than above your head. Inward pull strengthens. Acceleration begins not violently, but steadily, like stones sinking deeper into deep, still pond. Density here is astonishing, millions of times denser than water, yet still far from core's unimaginable densities. Hydrogen is no longer just plasma here, squeezed into forms that would seem alien on Earth, stripped of all electrons, its nuclei crushed into dense soup. If pressure could be measured here, numbers would defy comprehension. Hundreds of billions of times Earth's atmospheric pressure. This force keeps Betelgeuse alive, balancing fusion's outward push with gravity's inward crush. Every cubic centimeter around you contains more mass than entire Earth mountain. This stratification, convection above, radiation below, is no accident. It results from delicate balance between temperature, density, and the star's internal physics. In outer layers, where gas is less dense, convection is more efficient. Energy moves by physically transporting hot material upward. In deeper layers, where density is immense, radiation becomes more efficient. Energy moves as photons, scattering endlessly. Below it all, the fusion furnace itself. Even from here, deep within the star, you can feel, not hear, not see, but but feel the instability making Betelgeuse's life so short. Core fusion is no longer gentle, steady burn like the sun's. Betelgeuse has burned through its hydrogen and now fuses heavier elements in shells: helium, carbon, neon, oxygen. This layered fusion is unstable, producing energy pulses that ripple outward through the star like shockwaves. Each pulse stirs outer layers, sends matter streaming into space, and brings the star a step closer to inevitable collapse. As we sink, temperatures climb to tens of millions of degrees. At these extremes, matter behaves more like quantum fluid than anything known on Earth. Nuclei smash together at unimaginable speeds, forging elements that will one day drift through space, perhaps into newborn planet. This isn't just descent, it's time travel, witnessing the exact process that made atoms in your blood and bones. Now you sense it, a change in space's texture around you. Environment is no longer gradual slope of heat and pressure. It feels abrupt. Approaching Betelgeuse's fusion core, a place so extreme that known rules bend, break, and reform into something stranger. From here on, descent will be rapid. Outer layers may have felt endless, like drifting in eternal sunset, but the core is a different realm, entirely hot, dense, unstable, and, in red supergiant life, frighteningly close to catastrophe. Beneath chaotic convection zones, beyond roaring hydrogen seas, lies realm where Betelgeuse's true identity is revealed. This isn't just star center, it's its pulse, its heartbeat. Every flicker of light we see from across cosmos begins here, in endless fusion and energy release cycle. Through churning plasma oceans you have passed, through storms larger than our solar system you have descended. Now, as turbulence behind you fades, you enter a region unlike any yet seen inside Betelgeuse. It is still, not silent. 4-star's deep interior is never truly silent, but calm in a way that feels almost unnatural after outer layer chaos. Here, no giant convective bubbles exist, no vast boiling gas streams. Light no longer flickers and scatters. Instead, it glows steady, unblinking like light in midnight cathedral. This is Betelgeuse's core, where gravity and nuclear physics meet in delicate, violent, and ancient dance. It is, in every sense, the star's beating heart. If you could see core boundaries, you'd find it surprisingly small compared to Betelgeuse's full bulk. Betelgeuse itself is so vast that if it replaced our Sun, its outer edge would stretch beyond Jupiter's orbit. Yet its core, the star's true engine, is only a fraction of that, smaller than Earth's orbit, and much denser than anything previously experienced. It's a strange paradox. The larger the star, the more concentrated its heart. In supergiant like Betelgeuse, the core is like tiny jewels set with an enormous lantern. But this jewel glows with heat so intense it could vaporize entire planets instantly. Here, temperature soars to over 100 million degrees Celsius. Density is staggering, billions of kilograms per cubic meter. At this pressure, atoms aren't simply close together, their nuclei practically brush shoulders, held apart only by strange quantum mechanical forces preventing complete collapse. This isn't gentle fusion of stable middle-aged star like our Sun. Betelgeuse is old. It burned through its hydrogen long ago. Its heart is now restless, shifting furnace where multiple fusion layers occur simultaneously, stacked like onion skins. If you could peel away the core like onion, you'd find concentric shells, each fusing different elements. In the very center, helium nuclei smash together, forming carbon and oxygen process known as helium burning. Surrounding that, shells exist where carbon fuses into neon, neon into magnesium, oxygen into silicon, and in final, most fleeting stage, silicon into iron. Each layer operates at its own temperature, pressure, and timescale. Some shells may burn for thousands of years, others for only months. Silicon burning, the last step before stellar collapse, lasts mere days. Yet alien as it seems, this is living process. Fusion layers aren't static, they throb, pulse, respond to gravitational push inward and radiation's outward pressure. That is Betelgeuse's heartbeat. We call it heartbeat because, like living creature, the star exists in constant balancing act. Gravity tries crushing it into denser and denser ball. Fusion pushes back, generating energy radiating outward. The two forces are perfectly matched for now. But balance isn't perfectly smooth. In red supergiant, the core often contracts slightly, raising temperature and speeding fusion, which then pushes outward, causing core expansion again. These cycles can create real, measurable brightness pulses, which we can detect even from Earth. Betelgeuse is known for these irregular variations. Cosmic heartbeat we've watched for centuries without truly touching the source until now. If you could somehow exist here shielded from unimaginable heat and pressure, what would it be like? Light would be everywhere at once, omnidirectional, like standing inside a sphere made of pure sun. It wouldn't hurt your eyes because you'd no longer have eyes in any biological sense, but it would feel like brightness made physical. The air, though it is no air, would press against you from all directions with mountainous weight per fingernail. Time itself might seem to slow because here, in star's deepest part, distances and movements are measured in atomic collisions happening at nearly light speed. And in background, steady rhythm, not sound heard with ears, but pressure wave felt in bones, if you still had bones. It's expansion and contraction of supergiant's core. Slow breath of something that has lived millions of years and will soon die in brightest way possible. Everything the core does, every burning cycle, aims at one inevitable product: iron. Iron is fusion's end of road. Unlike lighter elements, fusing iron consumes more energy than it produces. When enough iron builds up in core, fusion can no longer hold back gravity. Betelgeuse isn't there yet, but it's close. Astronomers believe it could be tens of thousands of years away from that moment, or perhaps only a few hundred. In stellar scale, that's eyes blink. For now, the core beats on, burning layer after layer of heavier elements, each shorter lived than the last. It's like clock counting down, ticks getting faster and faster as end approaches. Every core pulse sends ripples outward through star's enormous bulk. These ripples are sound waves in purest physical sense, density, and pressure. Oscillations moving through plasma at hundreds of kilometers per second. By the time these waves reach surface, they can cause Betelgeuse to swell and contract, changing its apparent size and brightness. This is why Betelgeuse sometimes appears dimmer or brighter when viewed from Earth. We are, in a way, watching heartbeat travel through star's flesh and emerge in the only place it can, the photosphere. Right now, core's heartbeat keeps the star alive. But it's also a warning sign. Balance between gravity and fusion is delicate, and in massive stars like Betelgeuse, it becomes more unstable with age. Each new fusion layer burns faster than last, and as cycles shorten, pulses grow more erratic. One day, heartbeat will stop not because star has grown cold, but because it has grown too hot to sustain itself. When that happens, gravity will win an instant, and result will be explosion so powerful it will outshine entire galaxies. But that is not today. Today, as we stand or float in this impossible place, rhythm continues. It is steady, strong, ancient. In the presence of dying giant's life force, still burning against darkness, we linger here, listening to the pulse. In, out, contract, expand. Each cycle carrying weight of millions of years of history. Each beat reminder of delicate physics web that allows anything stars, planets, life to exist at all. When you finally turn away from core and begin rising again, light fades back into turbulence, heartbeat into roaring convection. But you carry it with you, that memory of standing at living star's center, where creation and destruction are the same thing. As we leave Betelgeuse's beating heart behind, we turn our gaze to next layer outward, where star's restless energy gives birth to storms larger than worlds, where mass is hurled into space in colossal waves. This is where Betelgeuse's outer atmosphere becomes light and motion battlefield, floating in a world that feels almost timeless. A place where seconds stretch into eternities, yet paradoxically, everything here races toward an ending that cannot be avoided. We are inside Betelgeuse Red, supergiant on the brink of one of the universe's most violent transformations. For millions of years, this star has lived in balance, fusion's outward push holding back gravity's inward pull. But now, that balance unravels. This is the final heartbeat, the moment before collapse. The deeper you drift, the more you notice something strange. It's quiet here. That absence of sound, Betelgeuse is far from silent. In truth, it roars with endless plasma churn, particle collisions, searing crack of photon birth. But to you it feels like muffled, otherworldly hush, as though the star itself holds its breath. Imagine standing in forest moments before thunderstorm. Wind dies, animals go still, air thickens with anticipation. That's what's happening here, except the coming storm is cosmic and absolute. At Betelgeuse's heart is iron core stellar fusion's final product. Iron is star's life dead end. Fusing lighter elements releases energy, but fusing iron consumes energy. There's no profit in it, no fuel for the star to fight gravity. Now, iron core grows heavier by the second. It's like stacking weight after weight on collapsing bridge, it can't hold forever. Pressure is staggering billions of times greater than anything reproducible on Earth. If you could somehow hold a teaspoon of this core matter, it would weigh more than mountain. Yes. If we could watch in real time, Betelgeuse's final hours would seem deceptively calm from outside. The star would still glow with familiar reddish hue, still pulse gently in brightness. But inside chaos. Each shell around core burns different element hydrogen in one layer, helium in another, carbon neon, oxygen, like cosmic onion of fire. Fusion in these shells speeds up wildly, desperate to fight growing gravitational pull. But its battle the star cannot win. In this moment before collapse, Betelgeuse's core has reached tipping point. Its mass is now greater than about 1.4 times that of our Sun, the Chandrasekhar, limit threshold beyond which electron degeneracy pressure can no longer hold gravity back. This is an equivalent of dam wall cracking under strain of swelling reservoir. Outward force that held the star open for millions of years is about to vanish in heartbeat. Your senses tell you something profound. Core structure is about to give way. Gravity is relentless. The moment iron core can no longer support itself, it will implode in less than second, entire mass collapsing inward at quarter of light speed. Before that happens, there's fleeting, almost serene stillness. Energy in fusion shells is still pushing outward, but core below crumbles. It's like standing on ship's deck in vast ocean just before a hole cracks beneath you. Imagine the star as a living being its whole life. It's been breathing. Core fusion is inhale and exhale that sustains it. But now lungs are filling with ash. Breath is faltering. One last faint inhalation, and then the star will collapse. How long before light can escape? To announce Betelgeuse's fate, something else will happen. Flood of neutrinos, ghost-like particles, will burst from collapsing core and race outward at nearly light speed. If we had sensitive enough detectors, we would know Betelgeuse was dying hours before its light changed. Astronomers call this neutrino flash, and it's universe's quiet way of saying it has begun. Here you are, watching core poised at cliff's edge. Next breath, gravity will take everything. And when it does, this massive star's outer layers will come crashing inward, slamming into suddenly rigid neutron core at unimaginable speeds. The rebound will trigger shockwave the supernova. Collapse is seconds away, and universe is about to witness one of its most dramatic spectacles. For now, let stillness of this moment settle in you. The star is silent, but only because it gathers breath for its final, deafening cry. The moment has come. For millions of years, Betelgeuse has burned, bloated, and pulsed in space's cold darkness. It has lived long life by cosmic standards, far longer than any human empire, yet fleeting compared to universe itself. Now balance that held it together is gone. Iron core has collapsed in less than second implosion, so fast that even light itself cannot register change before it's over. Star's heart is crushed into unimaginably dense neutron core. Outer layers still racing inward slam into this newborn neutron star at quarter of light speed. Collision releases shockwave of titanic force. This is instant. Universe holds its breath, and then the explosion begins. At first, shockwave struggles to break free. Star's outer layers enormous mass resists, pressing down like world's weight. But deep within, army of neutrinos, trillions upon trillions, streams outward, carrying away energy and weakening layers above. Then shockwave roars to life. In less than heartbeat, energy released is greater than our sun's total output over its entire 10 billion year lifespan. Betelgeuse, once serene red giant, is now raging cosmic furnace. Outer layers are hurled into space at tens of thousands of kilometers per second, faster than anything imaginable. In its first second, supernova releases as much energy as sun will emit in entire life. Still here, drifting within star's dying body. Suddenly, surroundings transform into white-hot chaos. Plasma surges past you, radiation saturates every direction, temperature leaps to hundreds of billions of degrees. In this furnace, atomic nuclei are ripped apart and reassembled in fractions of seconds. Gold, silver, uranium, and countless other heavy elements are forged here at Cosmic Alchemy that will one day seed planets, oceans, and life. Every breath taken on Earth contains atoms born in place like this. Watching existence's factory in its most violent mode, shockwave moves outward, Betelgeuse's outer layers expand at incredible speed. Like in first seconds, it's still hidden within star's body. But as minutes pass, star's surface swells rapidly, fiery sphere growing millions of kilometers wide. And then light arrives. Explosions, first photons burst free, marking supernova's visible birth. For Earth observers, Betelgeuse, already one of night sky's brightest stars, would suddenly blaze brighter than full moon. For weeks, it would outshine entire galaxies. Here, inside expanding fireball, you see supernova's paradox. Destruction creating creation. Stars like Betelgeuse are universe's great recyclers. Every atom heavier than hydrogen or helium in your body, carbon in cells, calcium in bones, iron in blood, was once made in star's core and flung into space by supernova. Without this violent death, universe would be sterile, filled only with hydrogen, helium, and darkness. Betelgeuse's end is not end at all, but beginning for countless future worlds. Hours pass. Shockwave has traveled millions of kilometers from core. Once coherent star is now expanding sphere of gas, dust, and radiant energy. In weeks, it will have spread across volume larger than our solar system. In years, it will merge with interstellar medium-thin haze of gas and dust between stars, enriching it with heavy elements. In millennia, enriched gas clouds will collapse under gravity to form new stars, planets, and perhaps new life. Betelgeuse will be gone, but its matter will live on. Amid chaos, at explosion's heart, something extraordinary remains. Neutron star. This remnant is no larger than city, yet so dense that a teaspoon of its matter would weigh billions of tons. It spins rapidly, beaming radiation pulses into space, perhaps becoming pulsar, cosmic lighthouse. Or, if collapsing core had been just little more massive, gravity might have won completely, crushing it into black hole place, where time and space are twisted beyond recognition. If standing under night sky when Betelgeuse exploded, you would see sudden, brilliant new object. It would be so bright it could be seen in daylight, casting shadows at night. For months, it would slowly fade, never completely disappear. Lingering ember of one of our galaxy's history's most dramatic events. Astronomers would turn every telescope toward it, studying its light spectrum to understand elements it had forged, energies it had unleashed, and its course fate. Now, you drift far from scene, looking back at expanding cloud where Betelgeuse once shone. It is beautiful. It is violent. It is everything at once. The star you knew is gone, but its death has sown seeds for new beginnings. And in time, atoms scattered here will gather again into new suns, new planets, and perhaps new beings who will one day look up at their own night sky and wonder, where did we come from? Answer will be written in ashes of stars, like Betelgeuse. Explosion has passed, but its echoes will travel galaxy for millions of years. The roar is over. Blinding light has dimmed. Shockwave has raced outward into deep black, carrying away star's skin, its bones, its breath. Now what's left? Where once Betelgeuse's enormous body burned for millions of years, there is now hollow emptiness, filled with drifting clouds of ash and metal cosmic giant's skeletal remains. Violence has passed, but consequences have only begun. Betelgeuse's outer layers, gas, dust, and heavy elements forged in death throes now expand in all directions. If you could hover here at blast's epicenter, you'd see ghostly glowing cloud, shaped by explosion's chaos. Plasma shreds still radiate heat and light, glowing in strange colors, blue-white oxygen and neon filaments, golden iron and nickel clouds, dull red silicon and sulfur veils. Each color tells element's birth story, nuclear fusion record written across sky, but not everything was thrown away. Deep within this expanding wreckage lies the core Betelgeuse's dense, shrunken heart. It is no longer star in traditional sense. It doesn't shine like sun. Instead, it is neutron star sphere, no wider than city, but with more mass than sun. Its surface is alien nightmare. Gravity so strong that dropped pebble would hit surface at half-light speed. Matter so compressed that single teaspoon would weigh as much as mountain range. Crust of neutron-rich atoms fused into exotic structures scientists call nuclear pasta, universe's strongest material. And if Betelgeuse's mass had been just a bit greater, this core would have collapsed completely into black hole, point from which nothing, not even light, could escape. Neutron stars often spin rapidly, especially just after birth. Betelgeuse's remnant could be rotating dozens, hundreds, or even thousands of times every second, sweeping electromagnetic radiation beams across space like cosmic lighthouse spotlight. If beams crossed Earth's path, astronomers would detect them as regular pulses, and Betelgeuse's death would be remembered as new pulsar's birth. Energy released in each rotation is staggering enough to power entire worlds. Yet over thousands of years, even this remnant will slow, cooling and fading, till it is little more than dark, frozen cinder drifting through galaxy. Meanwhile, debris cloud expands relentlessly. After just few years, it will be larger than our entire solar system. Edges are uneven. Some parts race ahead faster than others, sculpted by original shockwave, by magnetic fields, and by denser material knots. Astronomers on Earth, if they could watch in real time, would see this glowing shell gradually transform into something like Crab Nebula, vast, colorful, tangled remnant of supernova explosion. In thousands of years, Betelgeuse Nebula would be a dazzling landmark in Orion constellation, its filaments stretching across light years of space. Inside that expanding shell are riches beyond imagination. Gold, platinum, uranium, all forged in supernovas, final seconds drift among lighter elements like carbon, nitrogen, and oxygen. These atoms are seeds of planets, oceans, and living things. Without them, no worlds with rocky crusts, no rivers, no plants, no animals, no people could exist. Same iron in your blood, same calcium in your teeth, same oxygen in your lungs, all of it was born in supernova like Betelgeuse's. What remains after stars fall is life itself's building material. Debris will continue outward trek for tens of thousands of years. Eventually, shockwave will slow as it plows into thin interstellar medium sparse gas and dust between stars. There, it will mingle, enriching galaxies' raw materials. Over millions of years, enriched gas patches will collapse under gravity to form new stars, each surrounded by leftover dust and rock disks. Elements from Betelgeuse may join with material from other long-dead stars to form new planets. Some of those planets may have oceans, some may have continents. And somewhere, perhaps, life will rise breathing oxygen that once burned in Betelgeuse's heart. Even after nebula fades into background, Betelgeuse's story will not be over. Neutron star or black hole at its center will silently mark a place where a giant fell. Gravitational ripples of its collapse will have traveled across universe, detectable by future civilizations with instruments sensitive enough to feel space-time fabrics trembling itself. Heavy elements it created will become part of asteroids, comets, and future stars' cores. And perhaps billions of years from now, intelligent beings will stand on distant shore, look up at their night sky, and see faint ancient light. They may wonder, where did we come from? Answer will be written in Betelgeuse's ashes. Betelgeuse is gone. Red supergiant, that once loomed like burning ember in Orion, has left behind only its ghost remnant core, expanding nebula, and galaxy enriched with life's elements. Its fall is both ending and gift. Without stars' death, there is no creation. Without destruction, there is no renewal. Universe's constant cycle of birth, death, and rebirth. Now, as we drift away from Betelgeuse's quiet ruins, we carry piece of that truth with us. We are remnants of fallen stars. We are quite literally what remains after the fall. Betelgeuse's story is nearly complete, but not entirely. The storm is over. The story is told, while silence returns. Betelgeuse is gone, its light transformed, its voice quiet. But in that quiet, something remarkable remains: the slow, almost imperceptible heartbeat of the cosmos. Its rhythm so steady, so patient, that you can feel it if you stop just for a moment and listen. Universe breathes in centuries, exhales in millennia. The rise and fall of stars, flow of galaxies, all of it moves in pace far beyond human years. When we stand beneath night sky, we are looking not at fixed painting, but at living ocean. Stars drift, clouds swirl, worlds are born and lost. Betelgeuse was one of those waves' crests that rose bright and bold, then crashed in spectacular display before fading into the deep. Space's sea carries on, as it always has. And we are tiny ripples within it. Think of this. Every atom in your body, every molecule in your skin, bones, breath, began its journey in places like Betelgeuse. Calcium in your teeth was made in ancient stars' furnace. Oxygen in your lungs was cooked in giant heart that lived and died before Earth was even born. Iron flowing through your blood is supernova's dust. There's no separation from the stars. You're not merely looking at them, you are made of them. Betelgeuse's death is not just faraway sun's story, it is, in very real sense, part of your own origin. Imagine now that we're drifting slowly away from Orion. Hunter's belt still glitters in darkness, though one of its brightest jewels has dimmed. Where Betelgeuse once glowed deep, burning orange, there's now soft, expanding cloud faint, afterimage of giant's last breath, will be there for thousands of years, its light scattering across black ocean. Long after our lives have ended, long after our cities have crumbled, it will still be drifting. And somewhere, perhaps new life will be forming in nebula's embrace. Universe does not rush. It does not count minutes as we do. It simply turns galaxy by galaxy, star by star, atom by atom. We are so used to speed, 2 clocks ticking, 2 times pressing. Here, under night's dome, all of that falls away. Here, there is no hurry. Betelgeuse took millions of years to live its life. It will take millions more for its story to ripple outward fully, and in that span, countless other stars will rise and fall. We have journeyed deep into dying supergiant's heart, felt gravity's crush, fusion's heat, explosions, force that reshaped galaxy around it. But as our journey closes, lesson is not one of destruction. It is one of transformation. What falls apart becomes something new. What seems like ending is often beginning. Universe knows this rhythm well, and perhaps, deep down, so do we. Close your eyes. Picture yourself floating weightless in darkness. Far ahead, you see Betelgeuse Nebula's faint shimmer. Watch its tendrils slowly unfurl, moving so gently it feels like they are breathing. Behind you, Earth is tiny blue light. Above, Milky Way arcs in silver. Round you, silence. This is cradle you were born into. Stars are your ancestors, and in their light, you are home. As we leave Orion, let us carry one last truth. We are part of this endless story. It's not observers, but participants. Not outsiders, but cosmos children. Night sky is not something above us, it is something within us.
Betelgeuse's fall is not just stars' death.
It is a reminder that we, too, will transform, and that from our passing, new stories will rise. Sleep well, traveler. Stars will keep watch. Universe will turn. And somewhere far away, Betelgeuse's remnants will drift on until they find their way home.